heavily used by ROS, and ROS gives you this ability for components to communicate between each other. Some of the things that are particularly nice in ROS is that, let's say one of these nodes, remember all of these are pieces of code that are running on a computer. The computer might be on board the robot, the computer might be off board somewhere else. One of these nodes might, crash. Then it can be brought up again, start publishing, subscribing again. The rest of the ecosystem doesn't need to be brought down if one of the nodes just happens to crash. Another nice thing that happens is that ROS allows you for these nodes to be running on separate machines, right? So for example, I can have, obviously, the laser driver is going to be on board on the robot, right? So is the camera. But let's say that the localization and the path planner require a very powerful computer to run on, and the robot doesn't have such a powerful computer on board. Then what ROS, for example, allows you to do is to have these two nodes run on a separate computer, and then all of these nodes will be running on the onboard computer that's on board the robot, and then ROS makes all of this communication seamless for you. So, for example, ROS allows two nodes to talk to each other under the scenes over TCP, over UDP. These are some options that you have. So as long as you have such a connection, then you don't really care, which computer things are running on. ROS makes that all happen for you. And then finally, the other nice and very important thing that ROS does for you is that these various nodes don't have to be written using the same programming language, right? ROS supports as first-class programming languages both C++ and Python, and then a number of other programming languages are also supported to some level, right? So if you prefer to write, Python, then you can write some nodes in Python. You can use somebody else's nodes written in C++. So let's say, for example, that in this case, let's say that, the laser driver is written in C++, but the localizer is written in Python. They communicate through ROS, and ROS makes that all possible, right? So this is the plumbing aspect of ROS. It allows you to organize your code, and once your code is up and running, in this notion of nodes, ROS allows this communication between nodes using the concept of publish-subscribe. If we go back to the example that we're running here, let's put this off to the side so we can only see what's happening. So for example, one thing that ROS does for us, we can look at what data is being communicated. So in this case, right, I can look at what are called ROS topics, the topics that the data is coming on, ROS topic list. And for example, I can look at the joint states information. And what we see here is that somebody in the ROS ecosystem is constantly publishing this information. What is this? This is the simulated robot that is constantly telling the world, hey, these are my joint angles, right? So if you look at this vector of positions, you see that this is changing as the robot moves around. So right here. So this is the robot node that's running right now that's telling the rest of the ecosystem, hey, these are my joint values. And then the visualizer is what we say subscribing to that information, and then it's using it to render the robot in the appropriate pose. Right? So this is an example of information making its way through the ROS system. And that brings us to the next bit of what ROS is, tools. Right? Introspection. You can always look and see what data is being passed around between your nodes. Visualization tools. The visualizer itself, RViz, which is a tremendously powerful tool which can visualize lots and lots of types of data that's relevant in robotics. It's also very extendable. People have written their own plugins for RViz. So ROS gives you tools for visualization. Many other examples. You'll see a lot of that on the ROS wiki. So as you are building your own robot software, ROS gives you many, many tools for debugging and for in general, making your project move forward. The next thing that ROS gives you is actual capabilities. And this is, in a way, another one of the reasons that made it all happen in the beginning. Why something like ROS even came to be. And another thing I encourage you to do is to go on the ROS wiki and read about ROS history, because it's a pretty interesting read. Right? Again, robotics is an incredibly broad field. Part of it we're going to begin to cover in this class, but robotics is so broad that we don't even have a hope in a class or even in 2 or 3 to cover all of it, right? So let's say you are building a robot that needs to do a relatively complicated task that combines, it can combine navigation, it can combine perception, it can combine manipulation, but you are not an expert in all of those areas. And in general, very, very few people are. Again, robotics is very broad. Thankfully, in ROS, you have capabilities for most of these. So let's say if what I particularly want to focus on is the manipulation component. I still need my robot to drive around. I still need it to perceive the world. I care about the manipulation bit, but I still need all the other components. ROS will provide you enough to get you started in all of those areas. So it's code, it's open source code contributed by the community. Like a lot of open source code, the quality will vary. It's up to you to see, is this, a software package that's of high quality, that's maintained, that's coming from a reputable source. But you have a tremendous amount of pre-built capabilities in ROS that you can just start with. And all of those come from the community. People who have decided, hey, I'm going to contribute my code open source as part of ROS. So this gives you a quick way to get started, and it allows you to build a complete robot system, even though you are not necessarily an expert in all of those aspects that go into your robot. And that brings us to the last bit that ROS gives you, which is the ecosystem, right? Users, tremendous number of users. ROS has seen huge acceptance, especially in the research community. There are hundreds and hundreds and even thousands of labs that are actively using ROS, contributing code. It's seeing more and more acceptance in industry as well. You have a support forum on answers.ros.org, and there are other fora as well that you can use. There are conferences and events. For example, ROSCon 2017 is going to happen in Vancouver right after ROS, which is a big robotics conference. So ROS gives you all this ecosystem that you can rely on. So this is, in a nutshell, all of what ROS offers you. And put together, what has happened is, as I was mentioning, ROS has really become de facto standard, especially in academic research in the field of robotics, precisely because of these very, very enticing capabilities. In the world of industrial robots, right, which is a very well-established field with a history that goes back decades and that has had a huge impact on society, we'll talk a lot more about that in the future lectures, ROS hasn't been adopted as much, right, because that industry comes with its own long history of standards and tools that are very, widely used, so change doesn't happen as fast. However, where ROS really has taken a hold in the outside of academia is where companies are looking to quickly prototype new cutting-edge ideas. It's like, hey, I have an idea for a robot that's going to do something that no robot has ever done before, right? Maybe I want to build a robot that will clean the kitchen. That's an incredibly difficult task, but let's just use it as an example. I'm going to, I am a company, and I want to see if that's even possible. Well, it makes a lot of sense when trying a new cutting-edge idea to use ROS precisely because it gives you so many capabilities that you can start with. So you can prototype very, very quickly using state-of-the-art capabilities from this huge ecosystem that has contributed back to ROS over the years. So especially startups, robotic startups, are using ROS a lot for prototyping. Established companies are using it as well. And it is the de facto standard pretty much in academic research in robotics.